Utala, good morning, all. Good morning to all of you. We have 29, including myself. 29. So, how are the things now? Reduced to 28. Today I'm going to discuss a very important example. Okay, very important example. Which helps to learn a lot. Okay, yeah, which helps to learn a lot. So, as I'm always mentioning to you, this session helps for you to understand your notes. Okay, and what I'm doing is the supportive and more enlightening uh, discussions during the Zoom sessions for you to understand your notes better. Okay, so today topic I used to mention as balloon example. Balloon කියලා කියන්නේ අපි balloon ball example එක. Okay. Yeah. So balloons looks very simple, but this example is, of course, I use the balloon to make it simple because even from childhood, you know balloons. Even nowadays, for whatever birthdays or any celebrations, we use balloons to decorate. Okay, we use balloons to decorate. So balloons are, how to say, balloons are so familiar to you. Okay, balloons are so familiar to you. So this example would be a very nice one. Eh? Give me a second, guitar. Yeah, sorry about the disturbance. Yeah, balloon example. Okay. So here I take only one balloon. Okay, one balloon. Let's say this is the balloon. So this is a balloon I'm taking, just one balloon, and also I'm taking little more for this case. Okay, this example has a little more there. This example has sun. Okay, has sun. Also, this example has a clock. Okay.
Sir, excuse me, sir. Our presentation එක පේන්නේ නැහැ නේ.
Sorry, Buddha. Sorry. පේන්නේ නේද? හරි. Thank you. දැන් පේනව නේද පුතා? දැන් පේනවද? balloon example එකේ අපි ගන්නේ this is the balloon. Also I take sun and the clock. හරිනේ? clock එකකුත් ගන්න. So this would be quite interesting. This could be quite interesting. And I will take the one more thing. Puta, then pay now the presentation. Can you see the presentation now? Can you see?
No, sir.
Right.
Oh, sir.
It's a lifetime lesson you are going to learn. And I will take a ground. Okay. So you have ground, sun, balloon, and a clock. Okay. Yeah. Let's see how we are going to arrange this. Okay. Let's see how we are going to arrange this. So for this example, ground. Yes. Somehow balloon is on the ground. Okay. So this ground is not really matching. So you can see it, the balloon is on the ground. Yeah, on the ground. So I will make the ground a little bit smaller. So Balloon is on the ground. Yes. This is a very nice example. Okay, balloon is on the ground and yes, sun. Okay, sun. Let's say 6 a.m. Okay, 6 a.m. 6 a.m. the height. We place the balloon on the ground. Okay, 6 a.m. we place the balloon on the ground and we can see the sun is little far and it is not that strong. Yeah. So okay, the balloon, this is the original size, let's say, on the ground. 6 a.m. Later we will try to arrange this 6 a.m. And we will take 2 hours by 2 hours. Okay, 2 hours by 2 hours. So you have 8 a.m. Okay, sun is a little big maybe. So I will take only the balloon. No, yeah, with the ground it is good. Yeah. Arrangement takes little time. I'll put the balloon maybe. I will take the balloon maybe little big. Yeah, later we will discuss what makes it big. Okay. Yeah. And the sun looks closer, not to say closer, but bit more sunshine. Yeah. So then we will go to 10 a.m. 10 a.m. So 6 a.m. Have a little bit space here. 8 is here. Maybe 8. 10. sunshine maybe. AM. Yeah. A little bit big balloon. Okay. Then we will go for 12 noon. This is a very nice example. Eh? Looks very simple because thinking about the balloon is children's work. Eh? Yeah. 12 noon. More sunshine. Example. A bit more space. Eh? Yeah. Get more space. Thing is here. It's a thing is here. Okay. Yeah. 12 noon. It is big, little more big. Eh? Little big. Yes. 12, little more big. Then 2 p.m. Okay. 2 p.m. Now think about thermodynamics. Eh? Yeah, you can think about thermodynamics. Yeah. So you can see 2 p.m. Maybe still the environment is quite hot. Okay, 2 p.m. Maybe here. I need to get the space. 2 p.m. 12 noon. Somewhere here. 12. Yeah, it is nicely coming. Yeah. 2 p.m. Yes. I have to move the clock further here. This is 2 p.m. Right? Two p.m. Then we will look into 4 p.m. Okay. Then we will look into 4 p.m. 4 p.m. means sunshine is, not to say sunshine, the warmness of the environment looks reduce a bit. So 2 p.m., 12 maybe more, 2 is also say 4 p.m. Maybe like the 12 moon balloon size. 4 p.m. 4 p.m. Okay. Then after 4 is 6. Okay. After 4 is 6. So 6 p.m. maybe more cooling. Okay, 6 p.m. maybe more cooling. So 6 p.m. Sunshine is almost not there. And let's see. The balloon back to 6 a.m. time. Okay. So 4 means use this. Okay, something like this. Yeah, interesting, eh? Interesting. 6, 8, 10, 12, 2, 4, 6. Yeah, good. Good. Okay. So if I put this in the middle, how do you feel? This is the example. Okay, good. Do you know that if no air leaks from the balloon, this balloon is a closed system? Okay, this balloon on the ground is closed system. So if I start the story again, okay. Can't you hear well? Let me try. Now should be all right. Let me try. Yeah. Okay. I will do a little more arrangements here. Good. Can you all hear well? Okay. So original size. Let's see, if this is the case, you imagine. So, six, it is like this. Yeah. Interesting. 8, like this. 10, like this. 12, like this. Okay. 2, like this. 6, sorry, 4, like this. Little bit noisy today with the outside. Then come back to 6, like this. Okay. Come back to 6, like this. Okay. Should be okay. Okay. So you can see it's like this. So how long this process? 12 hours. 12 hours. Okay, so you have a lot of imaginations. Okay, but we will look into very general understanding. Okay, very general understanding. Don't think too much about the ground realities like wind, rain, clouds. Forget about this. Okay, winds, rains, clouds. You have to forget these things. Okay, because if you think all, we cannot make this example understandable. Okay, because this is not about weather. Okay, just an example. Okay, very nice. Good. Yeah, good. Yeah. Are you okay with the example? Yes. So forget about winds, rains, clouds, wind speeds, the level of cloudiness, nothing. Or shade, so nothing. So balloon put on the ground 6 a.m. and you leave it, and then slowly the sun is rising. Starting 6, we are observing this. Then the environment, Parisarit, the ambient, getting warmer, ground getting warmer. You are receiving a lot of solar radiation to the balloon. And because of that, because of the hotness or the energy level of the balloon is rising, so balloon is stretchable. It's a party balloon. stretchable. 4, this is slowly. By 8, this is little big. By 10, little more big. By 12, some more big. By 2, more bigger. Okay. By 2, it is more bigger. Somehow getting cold. By 4, it starts shrinking, and by 6, back to origin. Okay, by 6, back to original. Okay, back to the same situation like balloon rose at 6 a.m. Okay, so this is how it is. Okay, this is how it is. So what you can say, from 6 to 2, 6 to around 2, balloon is receiving some heat. Yeah, balloon is warm. So if we take the states, let's say 6, 8, 10, 12, 2 p.m. means 14 hours, 4 p.m. means 16, and 6 p.m. means 18 hours. Okay, so we have 1, 2, 3, 4, 5, 6, 7 states here. So states 1, not bad, not bad. 1. One is here. Okay. 2. This is 2. 3. 4. 4 means it's a state 4. Okay. State 4 means 4 for the balloon. Yeah, I think that is better. Yeah. 3, 2, 1. 5. 6. 7. Okay. 7 states. Okay. So this balloon. So from 1 to 7, it is back to origin. Okay. Original means temperature at 1 equals temperature at 7. Pressure at 1 equals pressure at 7. I mean the balloon pressure. Volume at 1 equals volume at 7. Of course, it's the same mass. Okay. So all the properties are the same. Okay. All the properties at 1 are same as all the properties at 7. Okay. So this is the master slide for today's discussion. So let me duplicate this without distance. Okay, let me do quickly this slide. Also, I will take a snapshot. Snapshot of this balloon example. This has ground, balloon, sun, and the clock, and 7 states. Nice. Okay. Nice. Good. Okay. Don't think too much about the balloon. Too much. Yeah. Good enough. Okay. So if I draw a graph, changing of 1 to 7 with time. Okay. Changing of 1 to 7 with time. The space. Maybe I'll use the text box. Oh, cannot. Can, really can. Don't worry, yeah. You can see a very nice time scale from 6 to 7. It's a nice time scale, 6 to 7. Okay, very nice time scale, 6 to 7. And state. If I draw the states here, it is something like, let me draw. Starting from 1, 2, 3, 4, 5, 6. Yeah. 6 is like this. Okay. 6. 7. Okay. Yeah. So we are developing this together. Not I am alone. So I need your inputs. One to 7. 1 to 7. See, somehow comes here. So this one is, I think, the right curve came a little bit down. What to do? Can I redraw this? Let me redraw it. 1, 2, 3, 4, 5, 6, 7, 8. That's it. Yes. Okay. 1 to 7 like this. So if I need to have one more axis here, this is not the final graph. This is not the final graph. So you can see that with time somehow this S1 looks like S7. So state 2, state 3, state 4, 5, 6, and 7. So S1 looks like S7. Okay. And S6 may be different. So if you really not thinking of the time scale, the other curve I'm drawing, if you are not thinking of time, irrespective of time, if you start from 1, 2, 3, 4, 5, and let's say 6, I don't know, 7 will be here. Okay, yeah, it will slowly come down, maybe slowly come down. And this, 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 this. Let me do it better after that. Eh? It is something like this. See, maybe something like this. Okay, maybe something like this. So it is come like this. So this graph is not very smooth, the red color one. So let me redraw it. Curve again. 1, 2, 3, 4, 5, 6. Slowly. Still the same, don't worry. Don't worry. Yes. So it's a curve line. Let's say 2 hours, 6 to 8 looks very fast coming back. So you can see this is a cyclic. Okay, this is cyclic. So that's how you can imagine this is a cyclic process. So after undergoing this receiving heat and releasing heat. Finally, in 12 hours, this balloon comes to the original state. So this looks like cycle. This looks like cycle. Understand? Yeah. This looks like cycle. If you imagine, here you have to learn a lot. If you imagine, if this happens to be this way, but this is not possible. This is not possible. This will not happen here. But I will draw this. If this can come, 5, 6, back to 5, back to 4, back to 3, back to 2, and back to 1. Okay? If I take this, can you see one more? See, it's moving from 1 to 6 and then come back. 6, 5, 4, 3, 2, 1. That is not possible. Okay? And if that's a possibility, we call it a reversible process. Okay? A reversible process. So you can understand what cyclic process means when you look into this. So this balloon undergoes some thermal interaction somehow, and in 12 hours time, it comes back. The red curve, you can see it is cyclic. And you may feel that cyclic process is possible. Cyclic process is possible. Okay? This cyclic process is possible. But if you think now about a reversible process, it is yeah. So if you think of reversible process here, this is the yellow curve. So yellow curve, you can see I'm going to change the color. Like this, maybe yellow or orange, whatever. Right. And you may feel that reversible process is impossible because to go back here, sun is shining. It is not possible to, okay? Because sun will go for sunset, and next day morning only sunshine. Okay? For this case, reversible process is not possible. Okay? Completely reversible process is not possible because of the sun. Okay? Reversible means following the same. But you see, one way we are thinking that, okay, it is not reversible, but this is a 12-hour long process. 12 hours long process. So here you can see always balloon feel like stable with the environment, like equilibrium. Balloons and the environment, there is a thermal balance. It is receiving little by little, 12 hours process, very long. Okay, very longer process. And balloon also not that uh, enlarging enlarging that much, but maybe a little expansion. Okay, so here you can see always there is a balance with the environment. So you can think in this way: balloon always has a balance. Balance means something like equilibrium with the environment. Okay, always has an equilibrium with the environment. Okay, as a balance or an equilibrium with the environment. Because of that, we can say this has a nature of reversibility, like even though it is not reversible. Because of the sun, you cannot come like this, but because of this 12 hours long process, balloon always has a balance with the environment. So the is process has, okay, or let's say process can be considered thermodynamically reversible. By nature it is not reversible, but thermodynamically reversibility you can consider in the process. I hope you can understand, Putana. So that thermodynamically reversible doesn't mean it is reversible always. So it has a balance or an equilibrium or a stability with the environment. මෙන්න මෙතනදී පොඩි experience එකක් වගේ. You have to have a good sense of this. Okay? You have to have a good sense of this. And it is more than the words. කියන වචන වලටම සීමා වෙලා මේක ගන්න බෑ පුතා. ඒ කියන්නේ නීතිය වගේ නෙවෙයි. නීතිය නම් හරියට වචනෙට definitions තියෙනවා. So when you do law, you have to exactly go word by word, meanings maybe, but when it comes to thermodynamics, having understand beyond the words in more realistic way, that is very important. Okay, so this is thermodynamically reversible, but by nature it will not reverse, but it is cyclic. Make a, we can think in this way. Okay, make a new විදියට නම් ගන්නවා නම් you have to consider for 24 hours. ඊට පස්සේ රෑ වෙලා හඳත් පායලා මෙහිම ඇවිල්ලා උදේ 6 වෙනකොට අන්න ලස්සනට බලුන් එක තියෙනවා. So if you think of 24 hours like that, you feel more cyclic nature of this, but I just limit this to 12 hours. I just limit this to 12 hours. හරිද පුතා කිව්වේ? මොකද රැට නම් මේක තව මේක පොඩ්ඩක් සීතල වෙලා ගිහිල්ලා පොඩි වෙලා it will come to, when it comes to 6, yeah, it is more cyclic. Okay, and you will feel the reversible nature even though it is not reversible naturally, but thermodynamically you can see the reversibility. So this process is naturally not reversible, but thermodynamically this is reversible. Okay, reversible process. Yellow curve. This is, I would say, not possible in this case because sun is going for sunset and next day only 2 p.m. sun will see at this point. Not possible in this case. Okay, not possible in this case. But 12 hours long process. It's a very slow process. So that balloon doesn't feel the change. අපි එමිති මේ වුණාට අපි නම් ඉතින් අවුවේ හිටගෙන හිටියොත් එහෙම කලන්තේ ඇදලා වැටෙනවා. That is different thing, but let's see, this is just some imagination. හරිනේ? හිතන්නකෝ. Just some imagination. එහෙම නැත්තම් මේ අවුව පායනකොට එළියේ හිටගෙන හිටියොත් එහෙම you cannot stand really under the sun, because for humans and animals maybe it's different, but for the trees it's a different story. But let's say, okay, so this is the balloon example. So here you can understand what cyclic process means. Cyclic doesn't mean it's necessarily reversible. Okay, cyclic means cyclic. Okay, does not mean the process is reversible. Cyclic කියන එකකින් කියන්නේ මේ reversible කියලා නෙවෙයි. It is cyclic. It will come back to the original state. Okay, so reversible process means, yeah, it's following the previous steps and go back to the origin. Not possible in this case because sun is not reversing. Okay, as the sun is not reversing, as the sun is not reversing. Okay, but this is 12 hours long process. Okay, so let me not possible in this case. Take the in this case out. Not possible as the sun is not reversing. But thermodynamically, because of this balance with the environment, let's say you can consider this thermodynamically reversible. Okay, so this may not be the best example, but you can understand this, and we are going to learn from this example more than this. Okay, you can learn more than this. So I believe this is okay for you. If you have any questions, you can ask. Okay, you can ask. So here I'm going to leave this. Oh, what happens? Yes. Okay. So I'm going to draw again another graph. Okay. Again, I'm going to draw another graph. Six a.m. equals 6 p.m. So you should understand what this equality means. Can උදේ හවසයි සමාන වෙන්නේ එක නෙවෙයි. Okay, it is not about equaling but the states. Okay, and then two p.m. I will take 2 p.m. Okay, I will take 2 p.m. So 2 p.m. is state 5. State 1. Okay, and also state 7. 1 and 7. Both are here. State 1, same as state 7. So I would say 1, 7. So state at 6 p.m. is equal to 6 a.m. is equal to state at 6 p.m. Okay, so this is state 5. So let me draw now. Okay, let me draw now. For the convenient. So it is like this. See? So there is a beginning. So there is a beginning. So let's say this is the beginning. The one is here. Okay. There is no end for the cyclic process, but let's say this is a kind of destination. Okay. This is a kind of destination state fine. And somehow it is coming back. So it is not reverse, but it is cyclic. So you can put some directions like this. Let's say I put here for this. Okay, I put here like this, and so this is cyclic, so you cannot say reverse. The reverse word you cannot use here. Reverse means this one go from 1 to 5 and come back on the same, then it is reverse. But here this is cyclic. So you cannot say even forward and backward, no such thing. But anyway, this takes time. So here time from 1 to 5. So here 6 to 2 p.m. This is 8 hours from 1 to 5 change. But 5 to 7 it is 4 hours. 8 hours, 4 hours, 12 hours together like this. Okay, quite interesting. So this is the situation. So it's like this. Okay, so this is reversible but cyclic. Reversible and cyclic. Okay, reversible but cyclic only. It is not reversed. Yeah. So let's say cyclic process. And if this process is not reversible, let's say, if this process is not reversible, that is possible, maybe, then you can draw like this, because dashed lines, we know that state 1 change to 5 and come back to 7. But you imagine the balloon is here always. The balloon is here, but now only the within the balloon things are changed. Okay, within the balloon things are changed. The balloon is originally, it is in the same place. Okay. Originally, it is in the same place. Finally, it becomes big. That's all. It's in the same place. So you should understand this. Huh? Yeah, it's happening in the same place. Okay. It's happening in the same place. So this is for irreversible but cyclic. Okay. Irreversible but cyclic. Cyclic, irreversible. Irreversible means shown the path by a dotted or dash curve. We don't know if this is irreversible. This is how you should mention the process, because you know only the states 1 to 5. In between, you cannot specify even maybe. To specify, this should be measurable. In irreversible, it is difficult to measure. Okay, somehow then you may have questioned that how come you identify the state 5, but anyway you consider it in this way for your convenience thinking. Yeah, so it's in the dash line. Yeah. Irreversible. Cyclic means back to 1 again. Yeah, so quite interesting. So cyclic but irreversible. In the first case, it is reversible as well as cyclic. Reversible means you know the each and every steps the balloon states is taken place. So you can plot this. So don't ask what are the axes. Yeah. So axes can be different. Okay. Axes can be different. So don't think too much about the axis at the moment. Okay. It is 10:27 now, Tala. It's 10:27. And we have to learn some more out of this process. Okay. We have to learn some more out of this process. Now, let's see. Now, let's see. Putala, you have to follow this very carefully. You have to follow this very carefully. So 1 to 5, state 1 to 5, this balloon becomes bigger and bigger, which says that from 1 to 5, okay, there is work done. Okay, W1 to 5 is possible. Work done 1 to 5. Okay, work done 1 to 5. One to 5. Work done 1 to 5. There is work done 1 to 5 because balloon expands. Balloon expands means the balloon is doing a work. The balloon is the thermodynamic system here, so you can see W1 to 5. Okay, W1 to 5. So do you know that when the balloon expands, it's doing a work? Let's say the other way. Let's say the other way, like this. So you have a balloon here. Okay, you have a balloon here, and you make this balloon smaller. You make this balloon smaller. Okay, you make this balloon smaller. Let's say you make this. So you are holding a balloon and you are making this smaller. That is difficult for you to do, but anyway, you are going to make this balloon smaller. Okay, okay, you want to make this balloon smaller. So what are you going to do to make the balloon smaller? Let's say you want to try to make it smaller. You hold the balloon and try to squeeze it. Can balloon පොඩි කරන්න කියන්නේ balloon මෙරි කන්න යනවනේ. ඒකට balloon පොඩි වෙයි කියලා හිතලා you are trying to squeeze the balloon. Balloon එක මෙරි කරනවා කියන්නේ. ඒක squeeze පොඩි කරන්න. Means you are doing some work on the balloon. The same way, when the balloon expands, means when the balloon is getting bigger and bigger because of the sun, means balloon is doing a work. Balloon is doing a work. Balloon is doing a work. So work done by the balloon is W15. Okay. So from 5 to 1, balloon is getting reduced, squeezed. Somehow the size reduced. So it is minus, yeah, let's say we're done W15 from the balloon. Okay, let's say this is from the balloon is yeah, done by the balloon. Done by the balloon. Done by the balloon. Work. Okay, work done by the balloon. Work done by the balloon. So by the balloon, so this is W15. Yeah. So now, work done by the balloon W15. Yeah, it is quite clear here. Then, in the returning from 5 to 7, means 5 to 1 again, because 7 equals 1. So, that is minus W15 for this, not to say returning, part of that from 5 to 1. Okay, 5 to 1. 1 to 5 it is W15. If so, 5 to 1 means 5 to 7 because 7 equals 1. 5 to 7 it is minus W15. Work done by the balloon. Okay, minus W15. So work done on the balloon, it's different. Okay. Normally, thermodynamic systems, on the system, our sign convention is positive. Work done on the system. So work done on the balloon, okay, work done on the balloon. For this case, it is from the balloon. So actually it is from the balloon. On the balloon, it's a negative value. Anyway, I just leave it as W15 and here minus W15. Okay. So that is work done. Okay. How about heat? Heat. Okay. How about heat? Heat on the balloon. Okay. Heat. I just heat on the balloon means the system. Q15. Q15. Heat on the system is Q15. Okay. Work done by W15. So even in reversing, okay, even in reversing, so heat on the balloon, let's say, it's a very simple example. This is minus because it's releasing heat somehow. Minus Q15. Okay, minus Q15. Okay, minus Q15. Also, let's say I'm putting all the expressions here. So when, because of this heat interactions, internal energy of the balloon, okay, there is a rise, let's say, delta U15, internal energy rise. Delta U15. Internal energy rise, delta U15. Internal energy rise, delta U15. So this is happened during this. Q15 heat receiving, okay, internal energy rise, delta U15. So here relatively, so here delta U15 is here in the completion of this cycle. Somehow this delta U15 released back and come back to the state 1. Okay, so internal energy rise is delta U15. Okay, now I'm using the same, but I'm going to change some words here. Okay, work done by the balloon, I just say on the balloon. on the balloon. SW15. So it is only the plus minus sign change only. So don't worry. I can put on the balloon. Because heat also on the balloon. Heat also on the balloon. Work done also on the balloon. On the balloon. Okay. This one. Minus W15. You never thought balloon example is that more complex. Okay. So cyclic but irreversible here. Yes. Cyclic, reversible. Yes. I think it is nice. Okay. Yeah. So you can say this. Okay. So if you write the energy balance, yeah, now is the game for the energy balance. So I will use energy balance here. I will write on the balloon work done and on the balloon the heat received. The heat received. Results. Results what? The internal energy rise. Okay. W15 plus Q15 is delta U15. Okay. This is from 1 to 5 change. So delta U15. Same way. For the return, let me save this for time because this is going to be a master slide. So balloon example is to be one. Today's 20. Zoom. Okay. So work done on the balloon is minus W15. Heat on this is minus Q15. And 5 to 1 internal energy loss is delta U15. See, all becomes minus. Minus. So you can write this okay, in this way as well. So let me try. questions? So I can write this way as well. Instead of minus W15, I put W phi 1, phi 2 1 plus Q phi 1 is delta U phi 1. Phi to 1 delta U change is reduction. So delta U phi 1 is minus delta U 1 phi. Okay, quite interesting. So, quite interesting. Yes. So these two equations are the same. No much difference. So how do you feel the balloon example? Some more to do, eh? Some more to learn. The only way to digest more is if you have questions, please raise. Okay, please raise the questions. It helps for others to understand this. අනික තව දෙන්නේ සෙල්ලම් බැලුම් එකක් නේ. ඒකෝට මේක තේරුම් ගත්තා කියන්නේ හැම දෙයක්ම තේරෙනවා. තේරුණානේ? ඒකම අනිත් පැත්ත තමයි if you have difficulties understand this, you should try somehow to make it understand. Okay, so that's a must. So this is nice. Okay, this is nice. The energy balances. Energy balances. Quite interesting. Energy balances. Yeah, very nice. Okay, very nice. Nala, you okay? Yeah, but any questions, Sanjeevani? Yeah. Sanjeev. Yeah, පුතා ප්‍රශ්නයක් තියෙනවද? Any question? Yeah, you raised hand, knowingly or unknowingly. Yeah, but anyway. Yeah. If you have questions, please raise your hand. Yeah. This is a master slide. I believe you can understand this. If you have questions, at least raise your hand, means you ask the question. And if you have difficulty raising the questions, at least take note what are the issues and try to make it understand somehow. I don't think it's that difficult. Okay, I don't think that's difficult because this is the balloon example. Okay, good. And the next one. Yeah. Before proceeding the next one, so I'm going into the little provisions. balloon example. Okay. Today, these are 4 items: sun, the balloon, the ground, and the clock. So starting 6, time measure.
පැහැදිලි වැහෙන්නේ නෑනේ.
ඔසේ පැහැදිලි වෙන්නේ පොඩි පොඩි එන්නේ.
එඩි දැහෙන්නේ.
ඔසේ
ඒක හොඳයි පා. දැන් කොහොමද ඇහෙනවද? දැන් ඇහෙනවද? දැන් ඇහෙනවද පුතා?
ඔසේ
ඇහෙනවනේ. පොඩ්ඩක් මේ මයික් එක පොඩ්ඩක් ස්ලාන් කරලා බලන්න. Can you see this slide? PowerPoint එකේ පේනවනේ. So balloon, ground, sun, and the clock. So 6 a.m. This is the situation of the sun, balloon, and the ground. Okay. 8 a.m. balloon becomes a little bit. Let's say this is imagination. Eh? 10, something. 12, more bigger. 2 p.m. more bigger. 4, a little smaller, and 6 back to the same. Sorry, 6 p.m. back to the same. And these 7 states of the balloon, because the internal conditions, we call it states. Okay, so state 1, 2, 3, 4, 5, 6, and 7. So here 1 and 7 states we consider same here, means same size. Same pressures and temperatures, we believe the ground come back to the same like the morning condition. ඒක හිම වෙන්නේ නෑ. මොකද ඒක හිම වෙන්නේ පහුවදා උදේ වෙනකල් විතරයි, because a day, cycle of a day is 24 hours. Okay? මෙතන මම ගත්තේ මේ lazy 12 hours cycle එකක් පුතා. ඒක 24 hours ගත්තම this is very nice. 12 hours cycle. එතකොට අපි ඒව imagine කරමු. එතකොට මෙන්න මේ example එකත් එක තමයි අපි ඊට පස්සේ බැලුවේ. For the next slide, we talk about what cyclic process means. රතු curve එක. Red curve ආයේ coding එකක් ගිහිල්ලා තියෙනවා. 1, 2, 3, 4, 5, 6 and 7 back to here. මේක ඇත්තටම ලස්සනට එනවා පැය 24ම ගත්තා. 6 night time 12 hours උද්දත්තන ලස්සනට එනවා. Example. Anyway, this is a cyclic process. Cyclic කියලා කියන්නේ, the cyclic means the balloon conditions at 6, the state, not only the balloon but the ground surrounding. It becomes important, right, when it comes to the system. Both comes to the same condition as 6 a.m. when it comes to 6 p.m. When in a 6 a.m. condition cannot be 6 p.m. But let's imagine that same condition comes. At the next day 6 a.m. condition. So we have to look into 24-hour cycle. You know that? Right. Anyway, 24 hours very nice. Make it. At last night, 6 next day 6 a.m. clock. This is a cyclic process, means the balloon comes to the original, and at the same time ground also comes to the original state together, and the balloon and ground both comes to the origin. Okay, cyclic. And the reversible means, yeah, so here the The reversible means, so what, 6 a.m. to 6 p.m. make a reverse winning, okay? 6 a.m. to next day 6 a.m. even that is not reverse. We can reverse win, but we can maybe sun case maybe ස්වභාවයේ මේ වෙන මේ movements එක ගත්තාම මේකේ තියෙන්නේ cyclicity එකක් විතරයි. cyclicity එකක් විතරයි. We cannot say reverse. ඒ කියන්නේ ඉර ගත්තාම 12 ඉඳලා 2ට ගිය එක කවදාවත් 2 ඉඳලා 12ට එන්නේ නැහැ. ඒකයි. මේකේ reverse එකක් නැහැ. ඒ වුණාට even though the sun from 12 to 2 cannot never be reversed from 2 to 12. No, not. You can see this is a pretty long process. Pretty long process that balloon doesn't feel it change. It's a different example. Let's say this is a pretty longer process. If balloon doesn't feel the change, and even this change is so slow, if we assume that the ground also responding together with the balloon to the sun in a slow way, that balloon and the ground are at somehow in a balanced situation. Can you heat transfer in ground to balloon? Ground to balloon. It's a body interaction. They come equilibrium, it's balanced somehow. It's a very tiny change experiencing with a tiny change of time. Okay? Drastic changes. So that's what we call it reversible. Again, process kuda change then in natika. Faster process reversibility we can imagine if the changes are not that much compared to the cycle time. So what anyway, the reversibility, that is thermodynamics reversibility, means the thermodynamically reversible nature doesn't mean the process is reversible. Thermodynamically reversible can be balanced. එකකින් කියන්නේ මේක ඇත්තටම රිවර්ස් වෙනවා කියලා. 12 to 2 ගිය එක 2 to 12 එන්නේ කවදාවත්. That is from 12 to 2 තමයි. තේරුණානේ? That is from 12 to 2. මොකද නැගෙනහිරින් පායලා බස්නාහිරින් තමයි බහලා. රිවර්ස් වෙනවා නම් ආයි බස්නාහිරින් පායලා නැගෙනහිරින් බහින්න මේකක්. තේරුණානේ? That is not reversible, but the process is so slow, we can imagine. And the changes are very slow. Heat interactions are extremely slow. If we imagine that way, there is a kind of thermodynamically reversible nature. But naturally it is not reversible. So it's a good lesson we are taking from this. Clouds more knowledge, more learning parts are coming further. So we just plot this. So against time, and the vertical axis may be whatever. It's about the state. So slowly S1, 2, 3, 4, 5, maybe the vertical axis. Finally, S1 and S7 becomes in the same line, the horizontal line. But the time scale 1 to 7 is 12 hours. 6 a.m. to 6 p.m. Don't worry, yeah? Same one now. Did it in this way. You have 2 axes. Don't worry about the axis. 2 axes. One horizontal axis may be time, and the other one refers the state. So this only tells that state 1 and 7 are the same and state 5 is different from 1 to 7. And එච්චරයි මේකේ ගන්න තියෙන්නේ පුතාලා. මේ axis vertical s axis එකෙන් ගන්න තියෙන්නේ 1 and 7 same states and 5 is a different state from 1 to 7. That's it. And horizontal axis, you can say it's a time axis. So it takes time. So time and state axis. Okay. So state properties, anything can be anything. Don't worry at this time. So state at 6 a.m. equals state at 6 p.m. That is state 7. So state 1 at 6 a.m. is equal to state 7 at 6 p.m. So state 5 is different. So 1 to 5, it's changed. And 5 to 7, back to 1. So you can see this is cyclic. Okay, that's what you are learning. It's cyclic. And the solid line says that it is slow and even a little changes, even 2 hours by 2 hours, you know where the balloon states means. Means you can recognize the intermediate states between 1 to 5. If it is well recognizable, that should be reversible. So solid line says 1 to 5 is reversible. And 5 to 7, solid line says 5 to 7 also reversible. So this is a reversible cyclic process as we have discussed in the previous slide. Reversible. If irreversible means if not reversible, 1 to 5, in between you cannot have a solid line. Example, the engines. Let's say the internal combustion engines or whatever engines turning at high speeds, sometimes reciprocating. So it is very difficult to recognize the intermediate states. And also it is irreversible. So like that situations, if 1 to 5 is such irreversible and difficult to recognize the intermediate states, you can go with dash lines from 1 to 5 and 5 to 7. Okay, so you can go with this. So drawing dash in this example, it is okay, and even draw solid lines also okay. This for the understanding purposes. So this is cyclic irreversible, shown the path by a dotted or dash curve. Okay, this is a closed curve you can see. You have a beginning and you may have the ending at the same, or anyway we have this fine end state, but it comes back to 1 or 7. 1 and 7 are the same. So 1 to 5, work done means the balloon expands, means somehow there is a work interaction in the system with the surrounding. W1 to 5. So I would say here work done by balloon, because balloon expands means the work is done by balloon. The piston එකක් අපි හිතමුකෝ expand වෙනවා කියලා, piston එකක් move වෙනකොට power stroke එකක, so your air quantity or the hot air or gas expands. So here also the balloon, the air becomes hotter and energized, and this air expands. That's why the balloon seems to be bigger. Okay, so same way, for the work done, there is some heat receiving, heat on the balloon Q1. Fine. Work done I put as W15. This is out from the system. Okay, you can imagine it. Okay, so the internal energy also there can be a rise because the volume change and your temperatures change, somehow the internal energy levels change. Back to 5 to 7 means to the original, same as at 6 p.m. Nabuta. So there can be negative heat on the balloon can be negative. Work done by the balloon is negative means now this is squeezing. Okay, this is squeezing, getting squeezed. Somehow, well, now let's see work done by the balloon. Okay, somehow you can see. Later we are going to evaluate the work done. So the energy balance W15 plus Q15 during this 6 to 2, okay, is delta U15. So 5 to 7 means 2 to 6 p.m. So minus W15 minus Q15 is minus delta U15. W51 Q51 delta U15. Don't worry about this and this time, but I believe you have some understanding on this. Okay, so 1 to 5 you can see positive signs, but 5 to 1 you can see some negative signs, but try to get clarified this. Okay, that's all. That's all. And then I'm going for the next. I'm going for the next. That is to evaluate W15. Okay, to evaluate W15. W15 evaluation. So let's see how to evaluate W. So this is the situation. How to evaluate W15. Okay. So this is what we are going to consider. So I take the heat out. So work done. Okay, let's say W15. Okay, W15. Okay, W15. So how to evaluate this? So 5. So I'm now going to consider that. Let's say this is 2 p.m. Sorry, 6, 8, 10, 12. Okay, 6, 8, 10, 12, 2. Okay, so 6 a.m., 8 a.m., 10 a.m., 12 noon, and 2 p.m. So this is W1 to 5. So this situation passes through these states. Today bit noisy with our surrounding. State 2. State 3. State 4. State 5. Okay. So that's all. So 6 p.m. to 2 p.m. So state 1 and 6, same as state 7. 6 p.m. That's true. So I have to put somewhere. Yeah. Okay. Good. So from 1 to 5. So state 1 is here. Same as state 7. State 1. Good. So evaluating W1 to 5. So here, let's say, you know that for a work done even by a piston in a piston cylinder engine, for work done, you are considering the pressure on the piston. That is the pressure in the system. Okay? So pressure is one thing that is responsible to create a force. Okay? That is responsible to create a force. So here also the pressure that makes this expand. This expansion, because of the pressure, somehow there is a work done. So one axis I will consider pressure axis. Okay, pressure axis. So let's say this is P. Okay, let's say this is P. Okay, let's say this is P. And expansion means it's a changing of the volume. Actually, it's an increase of the volume. let's say it is V. Okay, understand? Good. So you have to be very patient on this. When you understand this, be very patient. So let me take the wordings away here now, because my interest is work done. Okay, it's a curve. This way. So this is from 1 to 5. Okay. So at 1, pressure is P1. Okay. Let's say this is very important discussion we are having now. P1. Okay. So this is your P1. Okay. P1. We have one more hour only to understand this one. And generally for pressure we are using small p. Okay, small p. Big V is okay with the balloon volume. Okay, P1 is here. We have P2 here. P3 here. Okay, P3. This is P4. Okay, this level is P4. So I have to make this small. This is your P axis. P4 here. This is P5. Quite interesting. Shall we keep the 7? Yeah. Same way, we can have the volumes. Okay, we can have the volumes. See, move this upper edge. Good. V1. Okay, this is V1. Balloon initial volume. Okay, V1 corresponding to P1. Okay, corresponding to P1, V1. Yeah, okay. V2 is here. Very close. V3 because we know that for the work done by this air in the balloon is taken place because of this P and V. V4. V4. And V5 here. I will bring this to the peak. I will bring this to the peak. So V5. Understand? Good. So let's say now this W15 you can write this.
excuse me sir.
Yeah, beta.
සර් මේ ඕකේ බැලුන් එකේ පරිමාව වැඩි වෙන නිසා ප්‍රෙෂර් එක නියතයක් වෙන්නේ නැද්ද?
Pressure එක දෙපුතා.
ඔව්.
ප්‍රෙෂර් එක ඇත්තටම කියනවනම් මේක නොවෙනස් වී තියෙන්න පුළුවන් ප්‍රෙෂර් එකේ වෙනස් වීම ගණන් ගන්න අවශ්‍යත් නැහැ. මේ එක්සැම්පල් එකට අපි ගමු ප්‍රෙෂර් එක වෙනස් වෙනවා කියලා. හරි නේද? ප්‍රෙෂර් එකේ වෙනසක් වෙනවා කියලා අපි හිතමු. කොහොමද ප්‍රෙෂර් එකේ වෙනසක් වෙනවා බැලුම ලොකු වෙනකොට. ප්‍රෙෂර් එකේ වෙනසක් වෙනවා. අපි හිම ගමුකෝ. පස්සේ අපි ඒක ඩිස්කස් කරමු. W15 හරිද පුතා? has many components now. W1 to 2, okay, is one component. Okay, W2 to 3, another component. Okay, and another component is W3 to 4. Example, 2 hour by 2 hour, W3 to 4. W3 to 4 plus W4 to 5. Okay, W4 to 5 is a very general way of evaluation. W4 to 5. Okay, so this is 2 hour by 2 hour. So W1 to 5 means sum of work done in every 2 hours. When you add together from 6 to 2, you will get this. 6 to 8, W1 to 2, 8 to 10, W2 to 3, 10 to 12, W2 to 4, plus 12 to 2 is W4 to 5. So together will give you the total work done, let's say. So pressure can be the same, don't worry. And now we have a different pressures. Okay, we have the different pressures. But we would say instead of pressure becomes the same, yeah, by right it's the same but little more than ambient. Little more than ambient. ඒකෝට මෙතන හිතන විදිහ තමයි ambient pressure එක same නා. 1 වල ambient pressure එක නම් 5 වලක් තියෙනවා. බැලුමේ stretch වෙනවා කියන්නේ බැලුමේ tension එක වැඩි වෙනවා. ඒකට බැලුමේ tension එක වැඩිපුර තියාගන්න ඇතුලේ pressure එක වැඩි වෙන්න ඕනේ. ඒකට pressure එකට තමයි බැලුම් එකේ tension එක balance වෙලා තියෙන්නේ. ඒකට බැලුම් එක ලොකුයි කියන්නේ ඇතුලේ pressure එක ලොකුයි. හරිද? The pressure එකක් තියෙන වැඩිපුර ගත්තොත් that is a little higher pressure. So P1, P2, P3, P4 and P5, there is a little increase in pressure. The pressure එකට compensate කරන්න balloon එකේ තියෙන tension. හරිද? Tension. You can balloon එක stress වෙලා තියෙනවා. Actually we call it the surface, the stress of the balloon. Tension කියලා කියන්නේ the stress of the balloon. කියන්නේ balloon නෙමෙයි. stress එක වැඩි වෙලා තියෙනවා. කියන්නේ balloon මේ rubber එක extend වෙලා ඒක stretch වෙලා ඒක stress වෙලා තියෙනවා. body force එකක් තියෙනවා surface එක දිගේ. The surface එක දිගේ තියෙන force එකෙන් තමයි pressure එකත් එක්ක balance වෙලා තියෙන්නේ. මේ ටික අල්ලගෙන ඉන්නවා. අල්ලගන්න බැරි තැන තමයි බැලුමේ පුපුරන්නේ. හරිද පුතා? නිකමට කිව්වේ මේ explanation එක that's how it's balanced. The ambient pressure same. So internal pressure is balanced with the stress of this enlarged balloon surface. rubber balloon කියලා හිතන්න this is a rubber balloon. හරිනේ? ඒකට අපි මේ විදිහට ගමු. So now it's a matter of evaluating separate W1 to W23, W34, W45. Okay. Similarly, W45. W45. So likewise. So let's see how to evaluate this. Okay. Let's see how to evaluate this. Let's see how to evaluate this. So, for this evaluation, I am going for a new slide. It is same. See what I am going to do. W45. For this one, I will take P4 to 5 average pressure. Okay. So here, I will take average pressure is P45. Average pressure. So P45 can be P5 plus P4 divided by 2. Can be. Okay. Can be like this. Okay. Like this. We have 1 hour. Don't worry. P5 plus P4 divided by 2. P5 plus P4. Okay. Let's say P4 plus P5. Plus P5 divided by 2. Average की निगरान को करना है. Divided by 2. Okay. Same way, but the screen shall make a pain or the පැහැදිලිව පුතා. Same way. Yeah, it's very nice. I will take the others as well. P34, 3 to 4. So that is P3 plus P4 divided by 2. I will make it a bit smaller. Okay, so you know how to make it. Okay, so I just put here yes. Okay, the other one P23. See, yeah. So here is P2 plus P3 divided by 2. But no need to write it, since you know how to write this. P23. Even P34 also need to write, you know how to write it. Same like P4. So you have P12 to cover the sun. So I will not write P12. Let me try P12. Put it here. Remove the sun a bit. P1. Okay, good. So this is P45. Okay, and now I take what? The volume expansion. V45. Engine negative. මේ විදිහමයි පුතා. So let me explain. P45, V45. Okay, you have V45 means corresponding from 4 to 5 average pressure. This is a volume expansion. So 4 to 5. Pressure change from P4 to P4. Volume change from V4 to V5. But here we are taking not the average, but the delta V. Okay? Delta V. 4 to 5. Okay? So, this is your delta V 4 to 5. Interesting? This is your delta V 3 to 4. This is your delta V 2 to 3, and I have no space to write delta V 1 to 2. I have no space. But there is a delta V 1 to 2 as well. Okay? Yes. And now, there is a delta V 1 to 2 as well. Okay? So delta V 4 to 5 is equal to what? V5, okay? V5 minus V4. V5 minus V4. Okay. It's V5 minus V4. V5 minus V4. We can put this modifier. I will do this. No other choice. Eh? Yeah. So, same way, delta V 3 to 4 is equal to V3 minus V4. Sorry, V4 minus V3. So that's how we take, not V3 minus V4. V4 minus V3. Likewise, okay? So you can take this V5 minus V4, V4 minus V3 like. What is this? We call it expansion, okay? So expansion 4 to 5 is delta V 4 to 5. That is what we call expansion. What expansion? Here, the gas or air in the balloon, the expansion, okay? So the volume increase. So expansion means volume increase, okay? Very interesting, eh? Very interesting. So we talk that expansion always causes, especially gases, causes work done. The only reason for work done is expansion means this is the changing of the volume. So if it's a contraction, it's a negative work done. Okay? Expansion. So this is expansion. Delta V means delta V 4 to 5 means expansion 4 to 5. Okay? So we should be very practical when we look into this expression. So expansion 4 to 5, this is 3 to 4. Expansion 3 to 4. Expansion 4 to 5. Very nice. Yeah. Expansion 2 to 3, likewise. The space is quite packed. I'm going to duplicate the slide. Now, let's see. Now I will write what is W2 to 5. Sorry, 4 to 5. What is W4 to 5? Let's see. W4 to 5. So let me take this equation aside. Six, 32. Okay. So this is W1 to 5. Right? So looking into W1 to 5. So I will take W4 to 5. W4 to 5. Okay, W4 to 5. What is W4 to 5? So you have to think about this, Putana. The pressure times pressure at 4 to 5. So pressure at 4 to 5, there is a little, how to say, variation. That's why I take the average. Pressure 4 to 5 times, okay? Pressure 4 to 5 times the expansion 4 to 5. Okay? Expansion 4 to 5. Expansion. expansion 4 to 5. Yes. That is W4 to 5. Okay. This is very interesting. No matter it's engine or whatever. So expansion 4 to 5 is the volume increase 4 to 5. Delta V 4 to 5. Okay. Sorry. Pressure 4 to 5 times the expansion is delta V 4 to 5. See, P 4 to 5 times delta. Okay. So this one, I would say general expression. Okay. General expression, I would say W 4 to 5. So that is actually delta W, because that is only for 4 to 5. Delta W is P times delta V. Okay, so multiplication too big. So let's say put the dot. P dot P times delta V P times delta. Okay, so W4 to 5 is, even you can write it as delta W4 to 5. So delta W is P times delta V, or even you can write W as, because W is the complete one, eh? So delta W is P times delta V, that is putting up. Okay, so W4 to 5 is P times delta V4 to 5. W4 to 5 is P times P4 to 5 times delta V4 to 5. This is quite okay. Six. So W4 to 5 is P times, means P4 to 5 times delta V4 to 5. Okay, or delta W is P delta. මේ මෙතන ගත්තාම ටිකක් හොඳට ග්‍රහණය කරගන්න ඕනේ. එතකොට කියන්නේ if you have a system with gas and somehow if this gas expands under pressure, කියන්නේ පීඩනයක් යටතේ මේ වාතය ප්‍රසාරණය, expansion කියන ප්‍රසාරණය නේ. සංකෝචනය වුණත් ඒවා contraction or expansion. So pressure times the volume change. Volume change එකක් තමයි කියන්නේ පරිමාව වැඩිවීමක් කියන්නේ ප්‍රසාරණය. පරිමාව අඩුවීමක් කියන්නේ ඒක සංකෝචනයක්. For the same amount of gas. The gas එක leak වෙලා you can contract it. With extra gas you can expand it. Here no such thing. You have a system, closed system, same gas. Now under pressure this expands. So your work done is pressure average times the expanded, the expansion or the volume change, delta V45, okay? So delta V45 means V5 minus V4, okay? Delta V45 means V5 minus V4. So, see, so delta V45 is here. I will write that one separate. So expansion 45 is delta V45. So delta V45 is V5 minus V4. Delta V45 is V5 minus V4. So P45 is, you know, P4 plus P5 by 2. So quite interesting. So that is delta. P45 is V5 minus V4. P45 means the average of P4 and P5 during that segment of expansion. So you can imagine that. So expansion times the pressure is the work done. Okay. So let me do one more slide. So W is pressure times expansion. Okay, pressure times expansion. So here, pressure times expansion. So W45 can be pressure 45 times expansion is delta V45. It's the same thing. Okay. Expansion. So delta V45 is V5 minus V4. P45 is the average P4 plus P5 by 2. Okay. Further expression is delta W is P times the expansion is P delta V. So that is delta W. Yeah. So put this in a different color maybe. Yes. So this is W45. So if this is W45, now you can write W45 is this. So I'll make it a little bit smaller. Same way, W34 is P34 times delta V34. Very interesting. Then W23 W23 is P23 times delta V23. Okay, and next W12 W12 P12 plus delta V1. Quite interesting, eh? So this is in between every 2-hour periods or intervals. Okay. And let's say now you are going for even a small one. Okay, that's why we can write a general expression using delta W instead of W12. Pressure there times delta V. Okay, so this is the more general, even for smaller time periods. So delta W is this. Okay, or even delta W can be W, also possible. So it's up to you to write W12 or delta W, one of them. Actually, even you can write delta W12, that is also okay. Because delta W is something like for that period. But W12 also okay, eh? No, don't worry about that. So you have all the expressions and it's a matter of adding this. Let's see the battery level. Check the battery level. Oh, give me a second. Yeah, I have to plug the charger. Yeah, Buddha. So I'm back. So I believe this is a master slide. You can now understand this, and further I have to continue this. Further I have to continue. Let's say this is quite complicated, not to say complicated. Let me develop this now in this way. Okay, this is very nice, but I'm going to take many things out. If I need, I will put it. Okay. 7, I don't need. 1 is here. Okay. 7, I don't need. And then I will redraw this. I will redraw this from 1 to 5. 1, 2, 3, 4, 5. Done. Okay, this is done, and I will make it more visible. Let's see. Line color, I will put black. Yeah, good. So this is the case. Let's see now. I will take this way. A general position. Somewhere this can be 1. This can be anything. Yeah. A general position here. Because every 2 hours, no such thing for here, because we purposely put the clock. Okay, we purposely put the clock. That's why. But we have the initial and the final 1 to 5. So P2, I don't need. P3, I don't want it. P5, yeah, I need P5 and a general P only. So even this arrows on it. This is P. The balloon. The corresponding volume is V. You may have V1, P1, and V5, V5, And general you have PV. Okay, that's all. So to do the work done W15. Yes. Now I bring this expression here. So W is P times delta V. Okay. W is P times expansion. That is okay. So I will take at P. So the expansion. So delta V. So same way, before P and after P. So I will take some little process around P. Okay. So the average is P. So this can be P34. Knows P34 like this. Okay, Butala? Good. So I will take that expansion like this. Okay, that expansion. Someone is calling, I believe, not from your class. Eh? Yeah. So can you see this delta V? Can you see this delta V? Can you see this delta V? Delta V in W equals P delta V. This is your delta V. Okay. This is your P. Okay. This is your P. This is your delta V. This is your P. So let me take P as well. P. Now this P looks like here means if I extend this P. So this height really the same as the P you are referring. This is P. Okay, this is P. So this is delta V. So same way, if you think of delta V, it is this. This is delta V. Okay, This is delta V. So I will put the delta V here. See here to here, delta V. So finally you can see that P times delta V
Hello, sir.
Hello.
සර් ඇහෙන්නේ නැහනේ.
Oh, hari. Very sorry, Buddha. Yeah. Thank you. Thank you for reminding. So we have 38. So this is delta W equals P delta V. P times delta V. So you can say this. So this is a very nice piece of knowledge. I have tried my best to explain this in the most simplest way. Okay, through the balloon example. So this is how. So this delta V can be from V3 to 4 or V4 to 5, or this delta V can be corresponding to 10 minutes, even 10 seconds, even to 1 second, even to 1 millisecond, means 1/10 of a second. Depends on the speed of the process. Okay. Example, for an engine 1 cycle, you cannot wait for 12 hours. Okay. So you have to consider very smaller time periods. So where is your clock? So I have to bring the clock also here. Okay. So here at delta t, okay, then it's complete. Delta t means time, small t means time, time difference. Okay, so this is very interesting. At delta t, at delta t, at delta t, delta w is p delta v at delta t. Okay, p delta v at delta t. Okay, good. So now, so if this is for delta t smaller time period, so it's a matter of evaluating the strip. So let me go to a new slide. Okay, so I have evaluated this strip. Corresponding, there can be another strip here. I will go for this. So this is something like, not to say exact, but almost different strips. Okay. See, adding the pieces. Here you have, follow the curve. Something like this. Okay. Finally, you have all this delta W as P delta V. So what is this? This is equal to area. Okay, delta area, small area, P times delta V. So you have underneath this PV curve, the total area becomes W. Okay. So I will take a new one. So this is delta W. So W is what? Summation of delta W. Summation means we use the sign sigma. I'm looking for sigma now. Where is sigma? Sigma. Capital sigma. Give me a second, I can find it. Sigma. Okay, sigma. Capital sigma. Okay, summation. Okay, of all the delta W's, we call sigma delta W. Okay, is sigma of P delta V. Okay, that is total area. Sigma delta areas. Okay, that is the big area under PV curve. Under PV curve. So that's how you see it. Okay. So that is the total. If we try to put it under the curve, this is your delta W. This is your W. Okay. So for all delta T periods. Okay. So that's it for today. So this is from the balloon example. So we have learned about the expansions, how it comes as P times delta V at delta T, and from the PV curve, underneath the PV curve. Okay, so your PV curve, let me bring the curve in front. Yeah, very nice. Now see, yeah. So it is quite approximate. Quite approximate. So when we use analytical methods or calculus, I think you know about the integration. Sigma is actually integrations in calculus. Integration can ekatu kirima sigma. Yeah. Sigma. Integration lakuna how do you know the integration sign came? Yeah. So don't worry about this. So let me show you. How the integration sign came. Do you know S? S. Let's say you know S. Even for summation, we use S. Summation means what? Add, 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 anything. So here we are adding what? P delta V's. P delta V, where is this? P delta V's. You add. Okay? Add, add. Okay? You can add all. Oh, sorry. See, you can add all for each and every strip. You can add. Okay? Each and every strip you can add. Each and every strip you can add. So I'm not talking about this now. So let's say if you take this S, I'm taking this S now. Okay? And I pull this S. How do I pull this S? I'm pulling the S. Okay? I pull this S. So then what happens when you pull this S? Yeah. It is something like I stretch this S. Okay, I stretch this S. So when you stretch this, okay, when you stretch this, so when you stretch the S, you will get this. Okay, when you stretch S, you will get this. Even I stretch this. I take S here. Imagine you stretch this. See, finally, this is integration sign. Okay, so S is summation. Don't worry about the integrations. It's quite easy. Integration is therefore there to make the things easier, not to make the things difficult. So whatever comes integration, feel happy to deal with this because for some maybe integration is new, but in calculus this is not a big deal. So summation is the integration. So later we will learn about this. Okay, but don't worry about the last slide. Let me remove the last slide to make it easier to you. not to remove, but I will take the signs out. So this is the one. So this is W, finally the work done. Okay. So that's all, Putala, for today. So if I need to summarize this, remember balloon example. Connect all your theories. If possible, you can connect to this. It's quite nice. And finally, we learn even PV diagrams out of this. And even we learn about work done. So remember, work done is pressure times expansion. Okay. It's a simple proof for this. Yeah. So next week I will prove pressure times expansion is work done. Okay. Pressure times expansion means the volume increase. Even increase can be actual increase or can be a decrease. If it's a decrease, it's a compression. Expansion, it's a true expansion. So nice slides. I believe all can understand this, and you know sigma summation. Oh, it's very good. So that's all. So I believe one student, yeah, very good, Putha. You asked about the constant pressure, and now you may have understanding that there can be little pressure differences, and this is not the real balloon example, but this is with many imaginations for us to understand the things we have learned about the closed system. The work done is P delta V. And the PV graph, we have learned about this. Yeah. So we have a sense of time, delta T, and energy balances. So this looks very nice. Okay. So it is very nice to learn this thermodynamics in this way with examples. Then you have some good understanding of this for some good use. Okay. Now you can feel that even if you design a very good balloon for some applications, definitely for outdoor applications, you need to know thermodynamics. Without knowing thermodynamics, even you cannot design a performing balloon. Yeah, that's it. So good. So thanks for being in the class for such long. Very good. That's all, Putala, from my side. Any questions? So let me stop the class now. So, Putala.
සර් මේ PDF එක ප්‍රසන්ටේෂන් එක වෙනවද?
මම ඉවන්න මේ තේරුණාද කියන්නකෝ ඉස්සෙල්ලා තේරුණාද? Right. I'm going to do the PDF now. PDF, okay, balloon example. Very good. Let me email it to you right now. චුටකින් පුතා email කරලා අතර කරමු. Thermodynamics හරි ලස්සනයි පුතායි. මේ බලන්න දැන් ඕක කට්ටියගේ ටෙක්ස්ට් එකේ තියෙන ඒවා. ඒව තමයි මම උගන්වන්නේ. ටෙක්ස්ට් එකේ තියෙන මම බලන්න මේකේ තියෙන වෙනස. මම ටෙක්ස්ට් එකේ කියනවා නම් no point. Now you can bridge some imaginations and experience with the notes. Now, give me a second, Buddha. Let me compose it. You can take address in the 2019. Tell me the email addresses. Email address කියන්න පුතා. Email address මතකද? Mac 2K19 නේද? එහෙම දෙන්නේ. email address එක දාන්න පුළුවන්ද මට? Hello? පුතා ඇහෙනවද? ඇහෙනවද?
UOVT MEC 19.
හරි. පොඩ්ඩක් ස්ටක් වුණා වගේ මේ. චුට්ටක් ඉන්න පුතා. Give me a second. I will stop sharing first. Right, then හරි වගේ. UOVT MEC 19. I can remember you රැවුල කපලා තින්නේ. තව වැවිලා තිනේ. Right. So the other one is UOVT 2K19. Right. Okay. Today notes. Today notes. So PDF. බලන්න පුතාවද කියලා. Did you receive it? හරිද පුතා? නේද? Okay. ආවද? හම්බුණාද පුතා?
තාම නම් ආවේ නැහැ සර් හැබැයි. ඔය සර් ඉන්බොක්ස් එකේ තියෙනවා මේ ඊමේල් ඇඩ්‍රස් එක.
හරි මම එව්වා දැන්. එව්වා. send වෙලා තියෙනවා. send වෙලා තියෙනවා. Today notes කියලා දාන්න වෙලා තියෙනවා. ආවනේ. UOVT MEC 19 and UOVT 2K19 man. හරිද පුතා? හරිද?
ඇඩ්‍රස් එක නම් හරි සර් තාම ආවේ නැහැ.
Definitely පුතා. කාට හරි එන්න
හරි
ඕන.
සර් හරි.
ආවද?
හරි.
ආවනේ?
තාම ආවේ නැහැ සර්.
ඒ පුතා. Don't worry. Right. You will receive it somehow. හොඳයි. ආවේ නැත්නම් මට message එකක් හරි දාන්නකෝ ආවේ නැහැ කියලා. මෙන් send වෙලා තියෙනවා. Okay පුතා නේ. Then bye then. හරි? Okay.
හරි සර්. ඕකේ.
Okay.
Okay.